Andy can mow 2 lawns in 3 hours. Billy can mow 7 lawns in 12 hours. How long would it take Andy and Billy working together to mow 60 lawns? So we've got to combine information about Andy's work with information about Billy's work to figure out some information about them working together. And this leads us to our first sort of our first option, our first must-know method for dealing with combined work. If I want to combine information about people or machines working together, well, I can do so, but I have to be careful about how I do so. I cannot, for example, add their times. That doesn't really make any sense. If we add this 3 hours and this 12 hours, well, that's going to lead to a bigger number when in fact it should take them less time if they're working together. And we also can't add, at least not directly, their work. The 2 lawns and the 7 lawns, it doesn't really make sense since they're spending different times for for that work. But what we can do, and this I guess is the most important takeaway from this video, what we can do, and we can call this combined work option 1. A very reliable, very versatile option. Combined work option 1 is this. We can't add the times, we can't add the work, but we can always add the individual rates to get the combined rate, the together rate. In formula form, we can say the rate of one worker plus the rate of another worker plus the rate of a third, and however many we want to include, we can just add up those rates, and that will give us our combined rate, our rate together. So here for Andy and Billy, well, we can use this fundamental principle of combined work, that we can go ahead and add their rates. So our template formula will be this. We're going to take Andy's rate, the rate of Andy, and add Billy's rate Billy, and that'll give us our combined rate, the rate together. So what are their rates? How do we find their rates from this information? Well, I guess it's worth doing just a little bit of conversion review. And well, what is a rate? A rate, if we're talking about work, a rate is just, well, it'll be how many lawns I do per hour, or how many gallons I pump per minute, say. Or in formula form, a rate, if we're talking about work, is just how much work we do per some amount of time. In fact, some people like to keep this relationship memorized with a little visual mnemonic. This little work triangle, the W on top and then RT at the bottom, and then this formula sort of built in there, right? The rate is W over T, rate is work per time, and there's 3 other formulas in here as well. We can say, well, the time is W over R. Time, if we want it, we can find it from work divided by rate, and work is R times T. Work is R T. Anyways, it's definitely relationships that we need to know, and if you want, you can use this little mnemonic triangle to memorize those. Here, though, we care about this one, right? We're looking for the rates. So, back to Andy and Billy. Well, what is Andy's rate? Well, we're told he mows 2 lawns in 3 hours. So his rate, which is work per time, well, the 2 lawns is the work, the 3 hours is the time, so Andy's rate is 2 lawns per 3 hours. 2 lawns per 3 hours. And Billy's rate is going to be 7 lawns per 12 hours. And this combined work principle here says we can add these rates, and that'll give us our combined rate, our together rate. So let's do so. Let's see. If I want to add, we got fractions here, so I guess if I'm going to add fractions, I need a common denominator. And Well, I've got a 12 down here, a 3 down here. I can turn that 3 into a 12 if I multiply the top of this by 4 and the bottom of this by 4. And that will lead to, let's see, 4 times 2 is 8 lawns per hour over 12 lawns per hour. That was just converting Andy's rate. And Billy's is still 7 over 12. And that leads us to 8 plus 7 is 15 lawns per 12 hours. Lawns per hours. Or 15 twelfths of a lawn per hour. 15 lawns per 12 hours. And if we want, actually, we can reduce this, right? We can say 3 goes into each of these, so we can divide top and bottom by 3 to get 5 lawns per 3 hours. Lawns per hour. 5 lawns per 3 hour. Or nope. 5 divide 12 by 3 is not 3. Divide 12 by 3 is 4. 5 lawns per 4 hours. All right, so let's finish up this question. We've got the crucial bit of information. That's what we wanted originally. That's our combined rate. So how do I answer the question? Well, let's see. I guess there's a few options. This is a rate, right? This is the rate. So we could go back to our formulas and say, well, we're looking for how long it would take them. So we could use our time formula right over here, right? We could say, well, the time is going to be the work of 60 lawns divided by the rate of 5/4 lawn per hour. Or what I like to do is I like to just think of it as a ratio. We know together the ratio, we know that the rate is 5 lawns per 4 hours. And that relationship will be maintained no matter how many lawns or hours we're talking about. So if we want to convert that to not 5 lawns, but to 60 lawns, well, we can just think of this as a ratio. 5 is to 4 as 60 is to what? Well, to get from our 5 to our 60, we multiply by 12. So to get that bottom number, we just multiply by 12 to get 48 hours. So it would take them 48 hours to mow those 60 lawns. And yeah, I sort of slowed down with this process here because I wanted to emphasize these two, I guess, must-know principles. But once you've got this, once you know, oh, all I have to do, well, one thing I can do, I should say, is just add these rates, then you can make quick work of many of these combined work questions. So that's combined work option 1. You can always add the individual rates to get the together rate. And while you're doing so, it can be helpful to keep in mind the relationship between work, rate, and time.